Okay, I think let's start with the session. So, hello everyone, a very good morning to all of you. Dear authors and the invited guests, a very warm welcome to technical session 5A. So, myself, Yashita, and I'll be your moderator for this session. I'll make sure that things run smoothly and maybe keep up the energy too. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the International Conference on Technological Intelligence and Business Strategies, which is TIBS 2026 Philippines. This conference is being organized in a hybrid mode, so the physical event was held yesterday in Philippines, and the virtual event is being held through Zoom on 23rd and 24th June, where people from all over India, as well as many from other countries, are present with us. So I hope you all will enjoy today's insightful and knowledgeable sessions. So in this session, we will be having a total of 8 presentations. Each presenter will be given 10 minutes for presentation, followed by 2 minutes for a question and answer session. I will give a gentle reminder at the 8th minute mark to every presenter, just to help everyone stay on track. Also, I have a small request to all the participants that please stay connected with us till the closing remarks. I promise that it will be worth it. If you have any kind of queries or updates, please feel free to drop them in the chat box. Me and my co-host will be addressing them. So, before we begin with our sessions, I would like to introduce everybody to our esteemed session chair. First, we have with us Professor Randy Joy Ventayan, who is the director of the International Accreditation Office at uh, Pangasinan State University, Philippines. He is an accomplished academic leader, researcher, and educator with extensive experience in higher education, quality assurance, internationalization, and academic accreditation. His work focuses on advancing educational excellence, research innovation, and global academic collaboration. So, welcome to the session, sir. Do you have something for us to say? Okay, so our second session chair is Dr. Minakhi Raut, who is an associate professor in the School of Computer Engineering at KIIT University with over 20 years of experience in teaching and research. Her areas of expertise include data science, machine learning, and generative AI, with active contributions to academic excellence, research, and student mentoring. So I request her to give some remarks to start today's session. Even Professor Randy, you can also say something.
Hello, sorry, I was disconnected a while ago. Am I audible now?
Yes, yes, you are audible, sir.
Yes, good day, everyone. On behalf of the organizers, the GR Foundation, I warmly welcome all presenters and participants to this paper presentation session of TIBS 2026. And I look forward to hearing your valuable research insight and engaging in meaningful and productive conversations later. So thank you very much.
Thank you so much for those words. Dr. Minakhi, you can go forward.
Um, Thank you, Yasita, for the introduction and for all the participant. It's for my the best wishes with you all. Please present your research work over here, explained and properly, so that others will also take away the research initiative from it. So thank you, everyone, and you can start the session. All the best to all the participants.
Thank you so much. So we can begin with our presentation. So I would like to invite Mainford Mutandavari. Are you there in the meeting? Okay, let me check once. Okay, so the first presenter is not present. Okay, so we have Komang Vidya Sedana Putra. Are you there in the meeting?
Yes, I am. Yes.
Yes, so he's here to present his paper titled as AI in Higher Education, Cultivating Critical Thinking in Social Learning Environments. Yes, sir. Are you ready with the presentation?
Okay, please wait. I will share my screen.
Yes.
I'm sorry, this I'm sorry. I'm sorry. I'm sorry. I cannot share my presentation. Oh, ya tadi bisa.
So if there is any issue, you can resolve that. Till then, we can proceed with the next presentation, sir.
Okay, please the next
Ye-
presentation. I will use
yes.
this.
Thank you. Okay, so the next we have Mary Diana Yamzon. Are you there in the meeting?
Hello, good morning, everyone.
Good morning. So she's here with us to present her paper titled as Data Driven Analysis of Academic Performance of BSOD Students at Tagbilaran City College using data mining techniques. So are you ready?
Yes.
Yes, you can start presenting. Also, I request all the participants that please take note of the time while presenting. You have 10 minutes. You have to wrap up within 8 to 9 minutes almost. So, and also make the session interactive as we are connecting virtually. So everyone ask questions, everyone can ask questions. So yes, you can start with the presentation, Mary.
Good morning, everyone. Is my screen viewing there? Your
Yes, it
screen?
is visible.
Okay. So, good morning, everyone. I am Mary Diana Yamzon. I'm here to present the study titled Data Driven Analysis of Academic Performance of BSO AD Students at Tagbilaran City College using data mining clustering techniques. Okay. Tagbilaran City College, like many Philippine higher education institutions, lack a systematic approach to identifying which subject in the BSOAD program were consistent hand, general education, and business mathematics, each requiring very different skill sets. This diversity makes it.
Mary, actually, we can see your notes.
Oh, I'm so sorry. Okay, sorry.
That's fine. That's totally fine. You just have to do in the presentation mode.
Okay, sorry.
Yeah. Yes, now it is visible. You can go on.
Okay, I'm so sorry. I cannot see my screen, my notes. Okay. Um, so where I am now. So the BSOI program is also unique in that it covers vastly different subjects like the shorthand, general education, and business mathematics. So each requiring very different skill set. This diversity makes it difficult for the institution to allocate resources and design support programs effectively. So, to address this problem, the study had four specific objectives. First, to build and clean a data set of student grade records. Second, to apply three clustering algorithms, the k-means, k-medoids, and agglomerative hierarchical clustering to classify subject difficulty. Third, to validate the clustering results using the Davis-Bouldin index and dendrogram analysis. And fourth, to translate the findings into concrete evidence-based recommendations for the college. For this slide, the study used the CRIS-DM framework within the context of EDM. This ensured a structured and replicable process from data collection to recommendations. The dataset contains 26,965 valid student grade records covering 68 subjects across the 3 academic year. All data were sourced from the TCC's registrar's office and anonymously to comply with the Data Privacy Act of 2012. It applied the z-score normalization before running the 3 algorithms and used Rapid Mining Studio as the analysis platform. So in this slide, K-means produced the best model, achieving the Davis-Bouldin index of 0.461, which is considered excellent. Since the DBI below is 0.5, it indicates very well separated and cohesive clusters. The algorithm classified subjects into 3 difficulty levels: the easy, moderate, and hard. The hard cluster is the most important here because it contains 21 subjects with a poor performance rate of 25.75%. That is more than 3 times the dataset average of 6.8%. This confirms that difficulty is not evenly distributed across the curriculum, but it's concentrated in specific subject domains. So in this slide, here are the top 5 hardest subjects ranked by failure rate within the hard cluster. And this ranking is consistent across all 3 algorithms. So number 1 is the OA113 and the advanced shorthand with the failure rates ranging from 7.81% to 14.07%. Number 2 is the OA112 or the foundation of shorthand. So these 2 subjects were unanimously ranked first and second by K-means, K-medoids, and agglomerative hierarchical clustering. So ranked 3 through 5 very slightly between the algorithms, but they consistently feature GE1 or the understanding the self, GE4, mathematics in a modern world, and the business mathematics subjects. The converge across 3 methodological different algorithms is significant. It means that the difficulty signal is real and not an artifact of any analytical choice. So why are these subjects consistently the hardest? For the shorthand, the answer lies in cognitive load. Advanced and foundational shorthand requires all students to process the audio input, recall symbols, and execute fine motor skills simultaneously. A complex psychomotor cognitive task that many students find overwhelming. So gaps in the OA111 directly predict failure in OA113. For the quantitative subject, research shows that students who came from non-STEM senior high school tracks, which is common in our student population, arrive without any sufficient mathematical foundations when they entered in this subject or in this course. And for GE1, the challenge is different. It requires abstract reflective writing, which is difficult for students who are more task-oriented and procedural in their learning style. Based on these findings, recommend 4 specific intervention. 1, requires students enrolling in OA113 to complete structured shorthand laboratory practice before their prerequisite grades are finalized. 2, offer mathematics bridging program and diagnostic assessment at the start of each year to address numeracy gaps in quantitative subject. 3, implement a week 3 early warning check in OA111 so at-risk students can be referred to support services before they fall too far behind. And lastly, adopt portfolio-based and differentiated assessment in GE1 and GE4 to accommodate students with diverse educational backgrounds. So the study has several limitations worth acknowledging. First is the only institution grade data was used. No demographic or socioeconomic variables that were included, which means external factors affecting grades are not accounted for. Second, the data comes from one institution over 3 years. So over 3 years. Third, the validation of agglomerative hierarchical clustering via dendrogram analysis is inherently more subjective than a quantitative index. Future researchers should expand their dataset to include the student level variables, extend the framework to other programs, a TCC, or similar institution in the Visayas region, and integrate the qualitative data from faculty, students for a more complete picture. For the conclusion, this study used three clustering algorithms: the k-means, the k-medoids, and the agglomerative hierarchical clustering, applied to 26,965 student grade records across 68 subjects, and consistently identified OA113 and OA111 as the most academically challenging subjects in the BSOI program. Quantitative and self-reflected subjects also appear persistently in the hard cluster. Multi-algorithm convergence gives strong statistical confidence to these rankings. Most importantly, these findings are not just academic, they give the TCC or the Tagbilaran City College a data-backed foundation for the curriculum reform, resource allocation, and targeted student support. So that is all my study. Thank you for your time and attention. So any questions?
Any of the session chairs have any questions for her?
Yeah, thank you
Yeah,
very
Yeah.
much for the presentation, Ma'am Mary Ann. No. How do you ensure that the clustering result reflect true instructional difficulty rather than just grade variability or just cohort effects?
Sir, may I repeat the question po?
Yes. How do you ensure that the clustering results reflect true instructional difficulty rather than just grading variability or cohort effects?
It reflects on their grades, sir, from their prelim, midterms, and finals, and then
Yes, that is true. How can you ensure that the clustering results is true instructional difficulty? Or maybe from the practical standpoint, how can the administrators ensure that these findings translate into actionable curriculum reforms?
Okay po. So as for the results po, sir, is we show the administrator and also the instructors who teach those subjects or courses to really see that those students are really having a hard time in those subjects. So they recommended that in every end of the prelim, midterms, or finals, or at the end of the sem, they were planning to have a short sessions for those students that having a hard time learning those shorthand subjects po.
Okay, thank you for that. Just a few comments, ma'am. Maybe the Tagbilaran City College in the title section. If you're going to publish this into a journal, it is better to put it in the body section. Okay, that would be all. Thank you and congratulations.
Thank you.
Meenakshi ma'am, do you want to say something?
Yes, yes. Yeah, Mary Diana. I just have one question that there are so many limitation of K means. So what trigger you? What things that trigger you to use this K means for your study? Hello.
Yes, ma'am, may I repeat the question?
Question is that if you know K means has lot of limitations in it, inherent limitations. So why do you choose K means for your
I
study?
Okay. The reason that I use K-means because it is also first very there the answer already not already, but it shows the results perfectly. Like I said in the study, that K-means is the best algorithm to use in this particular study map.
How many columns do you have in your data set? Features?
Column. How many columns do I have in the data set, ma'am?
Yes, yes.
There are, I think, 5 or 6 columns.
5 or 6 columns. All these columns are of which type of values are there? Is it a continuous, categorical, rational?
It's categorical. May I repeat again, ma'am?
Your features in a data set having which type of values? Those are categorical values or continuous valued?
Those are categorical values, ma'am.
Categorical.
Yes, ma'am.
Then how did you apply it to the k-means? Because in the k-means, so you have to calculate the distance. So which distance matrix you have taken?
Uh,
Okay, in the k-means, how many iteration you have taken to got your final answer?
okay, for the K-means, I've used number 2 to until number 6 in order to find the very most call that one gathered study. So as I look to number 2 to number 6, number 3 is the most perfect um sort or gathered data for the results.
Okay, okay. So my side this much.
Thank you so much, Mary. Now we will move forward with Komang. Are you ready, Komang Vidya?
Thank you, everyone.
Yes, I'm ready, Miss. But
Yes.
I can start my video. I'm so sorry. My video is unable to start by host
That's
disabled by
that's fine.
the.
You can share your screen and start with the presentation.
Oh, okay.
Yes, it is visible, sir.
Statue-nya. Statue-nya. Jadi udah ini kan. Okay.
Hmm.
Um, Good morning, everyone. My name is Komang Widya Sedana, and I'm from Universitas Pendidikan Nasional or Uniknas in Bali, Indonesia. This article was created by me and Istimura Pokariwangsa and then Wayan Sri Maitri. Today, I would like to share our research on artificial intelligence in higher education. Our study examines how our pedagogy can cultivate critical thinking among university students, specifically through the role of social academic engagement. I hope our findings will be useful for educators, curriculum designers, and policymakers who are thinking about how to integrate AI into education responsibly and effectively. Let me begin with the context. Across the world, including in Indonesia, artificial intelligence tools are becoming a normal part of university education. Intelligent tutoring system, adaptive feedback platform, and AI writing assistants are now used in classroom every day. While these tools offer clear benefits, they save time, they personalize learning, and they provide immediate support. They also raise an important concern. When students rely too heavily on AI, they may stop thinking independent, they may stop questioning, analyzing, and evaluating information on their own. And then from a management perspective, critical thinking is not only an educational outcome, but also a strategic capability. In organization, managers are constantly required to evaluate information quality, access uncertainty, and make decisions under resource constraints. As AI becomes increasingly integrated into business operation, employees who merely accept AI-generated recommendation without critical evaluation may expose organization to strategic and financial risk. Therefore, developing critical thinking through AI-supported learning is also relevant for preparing future managerial talent. The core problem is this. AI tools may be turning students into passive recipients. Instead of forming their own ideas, students accept AI-generated answers. Over time, this may reduce their motivation to research independently and collaborate with peers. Looking at the existing literature, we identified a clear gap. Number one, most studies only measure academic performance and usability. The second, the role of social academic engagement as a bridge between use and critical thinking has not been studied adequately. The last, we do not yet fully understand the mechanism how AI pedagogy actually influences student higher order thinking. While previous study focused primarily on education outcomes, the implication extend beyond the classroom. In management and financial decision-making context, individuals increasingly rely on AI-assisted recommendation. Yet, little is known about how educational experiences with AI shape the critical evaluation skills required for future managerial and financial decisions. Our study has one main objective. That is to examine how AI-aware pedagogy enhance critical thinking through social academic engagement among undergraduate students in Indonesia. We tested four hypotheses. The first proposed that AI-aware pedagogy increases social academic engagement. The second proposed that social academic engagement strengthens critical thinking. And the next, test whether AI pedagogy has a direct effect on critical thinking. And the last, test whether social academic engagement mediates the relationship between AI pedagogy and critical thinking. Our study draws on three theoretical frameworks. The first is TIBS, technological, pedagogical, content knowledge. This framework argues that AI must be deliberate and intentionally aligned with teaching methods and learning goals. The second is student engagement theory, which states that students learn best when they are actively involved. And the third is critical thinking framework, which defines critical thinking as a multi-step process: interpretation, analysis, evaluation, inference, and self-regulation. Together, these three frameworks shape our conceptual model. There is AI-aware pedagogy drives social academic engagement, which in turn produce critical thinking. Our study used a quantitative research design. We collected data from 200 undergraduate students across multiple universities in Indonesia. We used purposive sampling with three selection criteria. The first, students must have used AI-based tools in their coursework. Number two, they must have participated in collaborative learning activities. And the last, they must have completed tasks requiring critical analysis or problem solving. Data were collected using a questionnaire with 5-point Likert scale, and we use PLSM version 4.0. We choose PLSM because it can simultan test both measurement quality and structural relationship, and it is particularly suitable for behavioral construct in complex technology in its environment. And then we have 200 undergraduate students. 83% were at least somewhat familiar with AI tools. And then 81% were in their second or third year of study, a period associated with more advanced academic tasks. 61% were female, reflecting common gender distribution in social science and education programs. Now let me present our main findings. First, our construct shows strong validity and reliability. All APE values exceeded 0.4, and Chromebus alpha and composite variability both exceeded the accepted threshold. And then for hypothesis number was strongly supported. AI-aware pedagogy has a significant positive effect on social academic engagement. And then hypothesis number 2 was also supported. Social academic engagement significantly predicts critical thinking. Hypothesis number 3, the direct effect of AI-aware pedagogy on critical thinking was not supported. And the last, the indirect effect path from AI-aware pedagogy from social academic engagement to critical thinking was significant. So, hypothesis number 4 was supported. The key message here is clear. AI alone does not produce critical thinkers. It works by creating social adjustment learning first. This finding is particularly important to management practice. Organizations are investing heavily in AI-based decision support system. However, our results suggest that technology itself does not automatically improve decision quality. Human interaction, discussion, and collective evaluation remain essential for developing sound judgment and reducing the risk of blindly accepting algorithmic recommendation. And then our discussion highlight 4 key points. The first, technology alone is not enough. The second, social academic engagement is the critical bridge. Number 3, the mediation result confirm the theoretical mechanism predicted by both effect and student engagement theory. And the last, we must acknowledge practical challenge. Differences in educator competitions, limited digital infrastructure, and unequal access to tools can all hinder effective implementation in contexts like Indonesia. And then theoretical contribution, the first, we extend the TPEC framework by showing that AI integration drives engagement, which then drives cognitive outcomes. The second, we advance student engagement theory by empirical confirming social engagement as a measurable mediator between AI enhanced pedagogy and higher order thinking. And number 3, we challenge techno-optimism. Our data provide evidence that simply adopting AI in education does not guarantee improvement in critical thinking. This is an important question for policymakers who may see AI as a shortcut to educational quality. And the last, we contribute empirical evidence from Indonesia higher education, a context that remains underrepresented in the global AI-aware pedagogy. Practical implication for curriculum designers must build learning activities around AI generative context, and policymakers invest in educators training for AI literacy. And then the conclusion is AI pedagogy does not directly improve critical thinking. The limitation, our sample comes from Bali and may not represent all context. And for future research, we encourage multi-country studies, longitudinal design, and the use of objective critical thinking assessment. And then thank you very much for your attention. Okay. Okay, I finished, Miss.
Thank you so
Hello.
much, Kumang, for your presentation. Do any of the session chairs have any questions for him?
Thank you very much, Sir Kumang, for that presentation. Just curious in about from your own teaching's perspective, what specific pedagogical strategies would you recommend so that AI use actively stimulates peer discussion and reflective thinking rather than just an individual task completion?
In my thinking, AI-aware pedagogy is defined in our study as the intentional and reflective integration of AI in instructional design. It means that educators do not simply introduce AI tools. They must design learning activities where AI serves a specific pedagogical purpose. For example, instead of asking students to use an AI chatbot to retrieve information, An AI-aware pedagogy approach would ask students to critical evaluate AI-generated outputs, compare them with other source, and discuss the implication with peers. So, uh, the difference is purposeful design versus passive adoption. AI pedagogy in this position serves as a prompt for deeper thinking and social engagement, not as a replacement for human reasoning. That's for me, Mr. Randy.
Yeah, thank you for your insights and also congratulations.
Thank
Okay,
you very
Meenakshi
much.
ma'am, do you have any questions?
No questions.
Okay.
Thank you.
So we will thank you so much, Kumar. So
Thank
we
you
will
very much.
move on with our next presentation. We have Hussein Sayed Ahmed. Are you present in the meeting, Hussein?
I will be the one to present the paper, Miss
Okay.
Yashita.
Okay, sure. So she is here with us to present the paper titled as Empower SK, a data-driven framework for boosting youth engagement using data mining tools. So are you ready with the presentation?
Yes.
You can start. You can start sharing your screen.
Am my screen visible?
Yes, it is visible.
Okay. So, good morning, everyone. As the advisor of um, the researcher, Mr. Hussein Al-Sayed Ahmed, I'll be presenting his paper entitled Empower SK, a data-driven framework for boosting youth engagement using data mining tools. So, as the background of the study, the Sangguniang Kabataan of Alilam Ilocos Sur faces persistent challenges such as the low turnout, no structured feedback, and programs based on the traditional rather than the evidence-based. So initial consultation across all 9 barangays revealed youth voices are largely unheard, wherein programs are repetitively sports centric despite of the evolving youth needs. So, data-driven governance has proven effective in improving youth participation, yet this approach has been applied to most of the SK governance in Alilem. So, empowering SK applies now the K-means clustering and sentiment analysis through Google Colab and Python, wherein there are 1,055 survey responses, generating now actionable youth engagement profiles and data-driven action plan grounded in the KDD or the Knowledge Discovery in Database framework. So the statement of the objective of the study first is to build and pre-process the quantitative data for the SK of Alilam across demographic factors, knowledge and awareness, the attitudinal factors, and also the SK supportive initiatives. Also the digital engagement and the Alilam youth profiles. And then next is the analyze and identify youth engagement profiles, followed by analyze the open-ended textual feedback using now the Google Colab and Python. And then the last would now be a action plan for SK programs to improve now and enhance the youth engagement and participation. So for the result of the study, the first is we have the key findings wherein 21 to 23 years old, wherein that's 387 of response had the largest group, 24 to 25 years old, transitioning now to workforce may need career link programming, and then the 18 to 20 years old, which comprises of the 314 respondents, composed largely of senior high school students, and most of these are at risk or they have disengagement. Another would be the educational attainment for the demographic profile. Key findings, most of the SK respondents as they are college undergraduate. That would be the large group that comprises 40% of the total respondents. Senior high school would be the second large, and then college graduate would be 259, and vocational graduates composes of the 96 respondents. Now for the pre-processed quantitative data, the digital engagement would be the highest, that gets now 4.14. The youth are digitally capable and connected, followed by 3.16 for the knowledge and awareness, wherein general aware of SK mandate but not they are not deeply informed. Also the attitudinal factors were in 3.67, that's broadly positive but not strongly committed. And then the last would be the lowest is the SK support initiative, wherein training deficit is the root cause of programming failures, mostly for the SK of Alilem. Now, applying now the K-means clustering, on the screen is we have now the figure for the elbow method, wherein determining now the optimal number of clusters. The result now would be the elbow method plots within the clustered sum of squares against the K-mean values, wherein it validated now by the silhouette score of 0.5, confirming adequate cluster cohesion and separation, wherein the K-means selected over hierarchical clustering and the DB scan for efficiency and interpretability of the result. Also, we have the youth engagement profile through the K-means clustering. The high active would now be the college undergraduate and the high digital literacy. Moderately involved are the college graduate because they are on the workforce transition. And the disengaged respondents are the senior high school, wherein they have a low income, and that would be combined 38.4 unserved respondents were in demographic deficit in the current SK programming. So on the part of the sentiment analysis, we have now 792 for the overwhelming majority. The neutral would be 241, which now the result would now be the governance implication, stating that SK programming reforms should build upon, not replace, the community-oriented core that the youth already value. So that would be the positive baseline of the result. The challenges that they experience, most of them, the poor evaluation, limited inclusivity, insufficient career programs, and poor planning. Now, the self-testing reinforcement cycle would now be undetermined officials, the poor programs, the low participation, and no urgency to improve. Another one for the sentiment analysis would be the improvement. What do they like to improve? So the top requests would be the digital feedback platform, coding workshop, mental health campaign, career seminars, and online delivery. So these are the top 10 keywords that was being part of the result of the study. So youth would be the highest part, and then the programs, we have the activities, the skills, initiative, leadership, confidence, the encourage, development, and teamwork. Top 10 now for the challenges. We have the activities, the program, the lack of engagement, youth limited, and so on and so forth. Top 10 keywords for the desired programs and improvement. You have the programs, you have the youth, the training, activities, workshops, and so on and so forth. Okay, so for the proposed data-driven action plan, we have the timeline for the action plan, wherein the first would be the awareness and inclusion. So that this would be on the first quarter of 2026. The program diversification, wherein that would be all clusters, the training workshops, the mental health awareness, career seminars, the digital literacy would be on the second quarter and third quarter. Digital transformation, so from the Google Forms, the SK social media dashboard, and the online town halls, that would be on quarter 2. And then the fourth would be the capacity building, the SK officials data literacy training, the facilitation of the workshop, and then the annual KDD cycle. And then the last would be the monitoring and evaluation. That would be the annual K-means pre-profiling to track now the cluster migration. And that would that would be for the whole Alilem municipality of Alilem. So for the conclusion, the objective number 1, the youth are digitally capable, having now engagement of 4.14, that's the highest. And then the gap would now be the root cause of all other engagement failures. So objective number 2, the K-means reveals three profiles. We have the high active, the moderately involved, the disengagement. Okay, so the third objective, the youth voice follows now a coherent three-phase narrative, wherein we have the appreciation, the diagnosis, and the prescription. And then the objective number 4, that would be the Power SK, proves that freely available tools such as Google Form, Google Colab, and Python can transform a rural SK governance into an evidence-based and annually replicable participatory system aligned with SDG 4, 11, and 16. So that would be all for my presentation, and I'm ready for the question and answer.
Thank you very much, Dr. Jenny. I believe this is a student thesis. May I just ask
Yes.
why you're not included as one of the author?
I am the teacher in charge po, Doc. Sadly, the author is in the hospital right now, and the advisor is not in the Philippines. So I am the one who presenting it.
Okay. By the way, congratulations. I just have two questions. The first one is since the data comes from 9 barangays and from just one municipality, I believe how generalizable this Empower SK framework to the other regions with different socio-political contexts. And just maybe you can just mention to me the future of this study, or what would be the possible generalization of this Empower SK to other regions or other barangay.
How are we going to compare? Is that the question?
Yes.
Okay. With the researcher, actually, if I'm not mistaken, Doc, the researcher actually tried to compare it with the, kasi Alilem is a far municipality in Ilocos Sur. So most of the programs actually is the traditional way. Now, comparing it with the city of San Fernando, most of the programs here would be different from Alilem. That's why part of the result and part of the proposal of the researcher is why not merging what is being used here in San Fernando, and they will be proposing it in Alilem. So that's
Okay.
one of the comparison.
Okay. I am not sure with this, but I would like to ask this one. Does the model measure the genuine civic engagement rather than just digital expression of interest?
No, Doc.
Mm-hmm.
No, it's just based on the demographic profile on what they have on the municipality.
Oh, okay. Okay. Just for the improvement, I would suggest if you plan to publish this one in a journal, it is better to remove the numeric information in the abstract. And
Thank
I
you so
think
much, Dr.
thank
Randy.
you. Thank you very much for the presentation.
Dr. Menaki?
Yeah.
Yeah.
Uh, Thank you, Dr. Janelle, for the wonderful presentation over here.
Good morning, Doctor.
Very, very good morning, ma'am. Acha, I just want have to know कि for this study, the data set you have collected or you have taken from any source?
No, they collected it based on the municipality. It is they created it. It's not downloaded from any source.
Okay. So I just want to know it is collected digitally or from a physical form?
It's a combination actually. They have the form, the printed form, and at the same time it's Google form.
Okay. So can you please light into us some of the pre-processing steps that you have carried out from the collection of the data and to give the model as an input?
Okay, as I've known, again, I'm just a teacher in charge of this study, but as I've known, ma'am, kasi in our institution, we are having the research ethics certificate. So before going now to the barangay, before having now the data collection, we have to be certified by the research ethics committee, followed by the researcher is from the municipality itself, and he is well engaged with the SK. That's why you having the data collection is very easy for him, because he's more engaged on the municipality. On the data processing, I think he used first he used the Excel file, then he cleaned it, followed by pre-processing it using Python, and then from the annotation and everything, he did it using Python programming.
Okay. Thank you for the explanation. Thank you.
Thank you, Dr. Janali, for your presentation. Okay, so up next we are having Renaldo F. Agunud. Are you present, sir, in the meeting?
Yes, ma'am, I'm here.
Yes, so he is here with us to present his paper titled as Forecasting Enrollment Retention and Graduation Trends Using Predictive Analytics, a Cohort-Based Analysis. So yes, you can start sharing your screen.
Okay, thank you. Okay, good day, distinguished session chairs and fellow researchers. I am Reynaldo F. Agunat from Holy Name University, Philippines, and together with my co-author, Dr. Janelia Mendez of Norma Colleges, also in the Philippines, I am pleased to present our study entitled Forecasting Enrollment, Retention, and Graduation Trends Using Predictive Analytics, a Cohort-Based Analysis. This research explores how higher education institutions can transform historical student records into actionable forecasts that support evidence-based institutional planning and decision-making. So higher education institutions continuously collect large amounts of student data through admissions, enrollment, retention, monitoring, and graduation records. However, many institutions still rely heavily on intuition and experience rather than data-driven forecasting when making strategic decisions. This presents several challenges. One is difficulty in predicting future enrollment levels. Second is limited ability to identify retention risks. There's also inefficient resource allocation and weak evidence for academic planning. So predictive analytics offers an opportunity to convert historical institutional data into meaningful forecasts that can guide administrators in making informed decisions. Our study addresses this gap by applying predictive analytics to a student cohort and evaluating forecasting approaches suitable for short institutional data sets. So the study had three objectives. First is to analyze historical trends in enrollment, retention, persistence, attrition, program shifts, and graduation. Second, to develop forecasting models for these six institutional metrics. And third, to compare the performance of three forecasting models, namely linear regression using ordinary least squares, Holt-Winters exponential smoothing, and autoregressive integrated moving average, or ARIMA, and also to determine the appropriate model for the data set. The CRISP-DM framework was adopted for this study, and the dataset consisted of 16,032 enrollment records with 8 variables. 1,916 students were involved. All their data were anonymized, and we only collected the student ID numbers. And this is also limited only to one freshman cohort, including 4 academic years from 2021 to 2025 and 28 academic programs. The data contained no missing values after cleaning and standardization. And because the dataset contained only 3 to 4 data points per metric, more sophisticated forecasting models such as XGBoost, Random Forest, Prophet, and Sarima were excluded, although they were originally considered. Instead, the models that I mentioned already were used for this particular study. Okay. The 3 forecasting models that were used for this study, as mentioned, is linear regression, Holt-Winters, and ARIMA. And these were evaluated using accuracy metrics, particularly mean absolute error, root mean squared error, and mean absolute percentage error. So the RMSE served as the primary criterion for selecting the best model. All the models were implemented using Python. So let's go take a look at the numbers. This tells the story of this particular cohort. The cohort declined from 1,916 students in 2021 to 2022 to 1,349 students in 2024 to 2025. This represents a 29.6% decrease. Most of the losses occurred during the first year. On retention, the average retention rate across transition periods was 88.57%. The greatest loss occurred during the first transition, where 279 students, or 14.56%, did not continue. However, persistence rates were much stronger. The cohort maintained an average persistence rate of 94.62%, reaching a peak of 96.50%. This suggests that once students enroll within an academic year, the institution performs relatively well in keeping them enrolled until the end of that year. On attrition, it mirrored the retention patterns. So the highest attrition occurred during the first year at 14.56%, highlighting the critical importance of early intervention programs. Program shifts revealed a significant spike during the 2022 to 2023 academic year. This is due to the migration of accountancy students to financial management and related programs. This migration explains why accountancy experienced an 82.4% decline despite many students remaining within the institution. So this is not reflective of the programs, but merely for this particular accountancy course. By 2024 to 2025, the cumulative graduation rate reached 17.91%, representing 343 graduates from the original cohort, although this is rapidly improving. Looking at the enrollment trend, you can see that the steepest drop happened at year 1 to year 2 transition. That is a loss of 264 students, or about 30.8% in a single year. This is the institution's largest single vulnerability. Separately, the program shift spike in 2022-2023 was significant since accountancy, as mentioned, lost almost entirely to financial management. However, these numbers are not dropout numbers, but program migrations, which is a different problem requiring a different institutional response. Now let's take a look at forecasting results. So enrollment is expected to continue to decline as expected for these kinds of cohorts. By the end of the third year in the forecast, only 783 would be left for this cohort. Retention is projected to improve at for the last year of the forecast, that would be 92.86%. Persistence is forecast to rise further at 98.41% at the last year of the forecast, and attrition is expected to decline. So program shifting is projected to stabilize around 3%. The observed spike in 2022-2023 was a unique occurrence for this cohort. Most importantly, graduation rates are forecast to continue increasing, suggesting that a growing proportion of the cohort will successfully complete their academic programs. Although I'd like to mention that the small number here is reflective of the underreporting in the original data set. Okay, to compare the models, as mentioned, accuracy metrics were used, and it came out that linear regression topped the models, and we based it in the RMSE. If you take a look at the shift rate and graduation rate, it has a very large MAPE, largely because of the zero records for the first two transition years, because of course, the graduation, there's no graduation during the first two years for this particular cohort. Okay, so the study provides several practical implications. First, the first year retention should be prioritized. The loss of 279 students during the first transition represents the institution's greatest vulnerability. Second, student progression data should be routinely analyzed rather than simply stored in databases. And third, predictive analytics can support enrollment planning, resource allocation, program evaluation, student success initiatives. The institutions do not necessarily need advanced artificial intelligence systems to obtain useful forecasts. Even relatively simple predictive models can provide meaningful insights when applied appropriately. In conclusion, this study demonstrated how predictive analytics can transform underutilized institutional data into actionable information. The cohort experienced declining enrollment but improving retention, persistence, and graduation outcomes. Among the forecasting approaches tested, linear regression provided the best overall performance, and the findings suggest that predictive analytics can serve as a practical decision support tool for higher education administrators, particularly in institutions with limited historical data. So that's it for this presentation. Thank you very much for the attention and the opportunity.
Thank you very much, Sir Rinaldo, for that wonderful presentation and a very timely study. Well, I just like to ask a clarification. Based on your presentation, you measure BSA to BSBA transition, but it is from board program to non-board program. Have you considered have you considered those courses might have really high turnover or something like shifting?
Actually, that's one of the critical findings of this study, which I'll be presenting to the Dean of the College of Business and Accountancy so that they can take a closer look at why this particular spike in the transition or migration happened. Because it's been also observed that probably there were not interventions that happened, or maybe they accepted those students having passed the initial screening exams for the BSA program, but eventually they found out that they couldn't finish or continue with the course.
Yes, I am not sure if there might be a problem with the admission process under BSA, or the student is forced to shift. Maybe that's some of the factors.
That can also be a possibility, sir. That's why it's recommended for them to really take a look at what's happening in the BSA program.
Okay, okay. Okay, just last question. Given your data set spans only for 4 academic years, how do
Yes.
you address the limitations of the time series modeling, specifically on the use of ARIMA and Holt Winters, which typically requires a longer sequence?
Yes. Thank you for the question, sir. Actually, Holt Winters and Arima were just included in the models for purposes of comparison because originally, when this was proposed, I was looking at a much longer period and including more than just one cohort. But then, since I was limited to this particular cohort of first-year students in 2021 to 2022, I still included those because we can still see that with Holt Winters and with Arima, you can say that now that they really need a longer period or more data points to consider in the study. But still, it showed also how even if it's a very limited data set, it also showed how the forecasting can also be done, although not really that accurate because of the limitations of the data set.
Okay, sir, I would like to congratulate you for this study. It's really helpful in your institution. Thank you
Yes,
very
sir.
much.
Thank you, sir.
Thank you also, Ma'am Yashita. Sorry for not waiting for you to talk first. Thank you.
No, that's fine. That's totally fine. Meenakshi ma'am.
Yeah, I'm here only. Okay. I just have one question that, as I
Yes, ma'am.
heard, there are three forecasting model you have chosen for your study. So, and I hope linear regression is performing outperforms than the other two model. Am I correct?
Yes, doctor.
So, have you ever checked for the overfitting of the model? Because ARIMA model is a adaptive model rather than the linear regression. And linear regression itself has a limitations it's have. So, is there any kind of analysis has been taken that why linear regression outperforms than these two models?
Uh, yes, actually, the main consideration at this point for this study was the limited data points for this. That's why, as I mentioned earlier, Holt Winters and Arima were originally considered because I was looking at a bigger or a larger data set. However, it still contributed to establishing how linear regression can help in forecasting with limited data set and also avoid overfitting. So that's how I came to uh, include Holt Winters and Arima with linear regression.
Okay, I just have one more question. For all these
Yes.
three models, the number of epoch, the iteration has been fixed or it is different from each other models?
It's the same. I ran them in the same data set, the same epochs or the same data points, so that I can have a baseline for all of these models. However, obviously, Arima underperformed because of the limited data set, and Holt Winters uh, was close to linear regression, but basically because it was basing the results of the linear regression when the Holt Winters was uh, applied to the data set. I hope that that clarifies it, doctor.
Dr. Meenakshi, do you have anything to share? Should we continue? I think she has left the meeting because of some issue. So let's move forward with our next presentation.
Okay,
So
thank you very much.
thank you so much, Ronaldo, for your presentation. Now, next up, we have Edimar Rato. Are you here, Edimar?
Uh, good afternoon, yes.
Yes, so he is here to present his paper titled as Predictive Modeling of Student Attrition and Retention Using Machine Learning Algorithms at Tagbilaran City College. So, yes, you can continue.
Okay, good morning, good afternoon, everyone. So I am Dimar Rato from Bohol, Philippines. Wait, let me just open my camera.
Yeah. You have to share the screen.
Okay, is my screen visible, ma'am?
No, your screen is not visible. Your screen is not shared.
Wait,
Uh,
how about this one, ma'am?
Yes, now it's visible. You can start.
Okay, so again, good afternoon, everyone. So I am Dimar Rato from Bohol, Philippines. So it is my pleasure to present this study entitled Predictive Modeling of Student Attrition and Retention Using Machine Learning Algorithms. So this research explores how machine learning can help educational institutions identify students who are at risk of dropping out. So student attrition remains a significant challenge both globally and locally. So in the Philippines, the Commission on Higher Education reported a college dropout rate of 35.15% during the academic year 2023 to 2024. Unfortunately, many institutions, including the Tagbilaran City College, often identify at-risk students only after problems have already occurred. So this study follows the input process output or the IPO framework. So the input consists of students' demographics and enrollment records. So this data undergo processing through data cleaning, encoding, and machine learning techniques, including random forest, gradient boosting, and k-means clustering. So the output includes identified dropout risk levels, significant risk factors, and student clusters. So these frameworks demonstrate how institutional data can be transformed into an actionable insights. So for this study, the data was utilized from 438 students enrolled between the academic years 2021 to 2024 across three academic programs: the BS Office Administration, BS Entrepreneurship, and the BS Tourism Management. So the data were obtained from the Registrar's Office of Tagbilaran City College and analyzed using Rapid Miner Studio. So the three machine learning algorithms were implemented by like the random forest, gradient boosting, and the k-means clustering. So prior to the analysis, data cleaning, encoding, and normalization procedure were performed to ensure data quality and consistency. Now, let's go with the result and discussion. So let us now examine the results obtained from the three machine learning models. For the random forest, so the random forest model achieved an overall accuracy of 59.59% and an AUC value of 0.575. However, while the model correctly identified most retained students, it performs poorly in detecting actual dropout cases. So its dropout recall was only 6.27%, meaning that only a small number of students who eventually dropped out were correctly identified. So this suggests that the model was heavily affected by class imbalance where retained students greatly outnumbered dropout students. For the gradient boosting, so the gradient boosting model produced a slightly higher accuracy of 60.51%. However, its ability to identify dropout students was even weaker with a recall of only 2.35% and an AUC of 0.508, which is close to random prediction. Although the precision appears high, the result is misleading because the model rarely predicted dropout cases. Therefore, the model was not effective for practical dropout identification. For the unsupervised restratification for the k-means clustering result, so unlike the previous models, the random and the gradient, K-means clustering groups students into three distinct risk categories. Cluster 1 emerged as the highest risk group with a dropout rate of 44.7% among 103 students. Cluster 2 represented the largest group consisting of 258 students with a dropout rate of 41.9%. Cluster 0 was classified as the moderate risk group with a dropout rate of 27.3%. So these clusters provide meaningful risk profiles that administrators can use to prioritize interventions. So to evaluate the quality of the clusters, now the Davis-Baldwin Index was used. So the model achieved a score of 0.967, indicating acceptable separations among clusters. So the result confirms that the student groups identified by K-means are sufficiently distinct and meaningful for analysis and intervention planning. Go with the comparative analysis. So when comparing all three models, it was observed that the supervised models achieve moderate accuracy but struggled significantly in identifying dropout students. So both the random forest and the gradient boosting suffered from extremely low recall values. So in contrast, as you can see, the K-means clustering successfully revealed meaningful students groupings and provided practical insights despite not requiring label data. So a result, K-means offer the most useful output for institutional decision making. So why K-means? So K-means emerged as the most practical model for several reasons. First, it bypasses the class imbalance issues that affected the supervised models. Second, it uncovers hidden patterns and student groupings that traditional classification model may miss. Third, it can be applied at the beginning of the academic year, allowing institutions to act proactively rather than reactively. Finally, the result clusters are easy to interpret and translate into intervention strategies. Okay, I think that would be all for my presentation. Thank you, everyone, for listening.
Anyone, any questions for him?
Thank you, Adima, for the presentation. Acha. I just have one question. What motivated you to investigate the same thing on classification as well as the clustering?
Oh, wait, ma'am, may you repeat the question? I was not able to hear it clearly. Thank you.
The question is that in the same investigation, why do you prefer to have classification and clustering both?
The use of the clustering and classification model is to see which model could be best suitable for this data. So I apply there the supervised and the unsupervised models, and I see based on the result that it seems that the clustering was the best and suitable model for this study.
The number of cluster already you fixed up?
Ma'am?
Number of clusters in this investigation is already fixed up, or you have got through the unsupervised learning mechanism?
You mean the how many clusters were used, ma'am?
Yeah. Because in the
Also,
classifications, number of classes, the clusters are already fixed. And in the unsupervised, you need to find out number of clusters are there in the data set. So my question is that number of clusters or number of classes are already fixed, or you have found using unsupervised learning?
so it was the number of clusters I used, ma'am, was based on the suggestions from that to use the three clusters, ma'am. So it was not literally fixed, but I have business suggestions.
Okay, so in what context you have compared both supervised and unsupervised learning together?
Well, the use model or what can I say is it is based on the selection of the models model for the supervised and supervised was based on the prior literatures on the effect shows the effectiveness on the date educational data mining. So there's a lot of literature that shows supervised models is effective in this kind of study. Also, there are studies that is effect. There are some literatures that states that unsupervised model is also effective in this kind of study. That's why I use both into this study, ma'am.
Okay, one more last questions. In the supervised learning, you have taken accuracy, F1 scores are the performance measure. What for unsupervised learning?
Again, ma'am.
You have used accuracy, F1 scores, performance measures for the supervised learning methodology to validate. So I just
Yes,
want
ma'am.
to know okay, what performance metrics you have used to validate the unsupervised learning techniques.
Okay, so for the unsupervised, I use the Davis-Baldwin index, ma'am.
Okay, thank you, Nadim.
Thank you, ma'am.
Sir Edmar, just a few comments. First of all, in your title, it is better if you can just remove Tagbilaran City College. If you plan to publish this one in a journal, since Springer is a conference proceeding, and I'm just curious about this one. Since Random Forest and Gradient Boosting showed the relatively low performance based on your result, how did you address the class imbalance problem during the modeling?
Well, it the it shows low recovery. The result was very low, so it is not literally effective. And then so I have just suggested into this study that in for future studies to include more variables that for like the grades and then so on, because in these studies I only use the enrollment data only, so that's plain. So maybe that's the reason why the supervised models or the gradient and the random forest only has a recall value. So I just suggested in this studies or in the recommendations that to add more variables for that for future studies, the class imbalance might, or the result for these models might improve.
Okay, thank you.
Thank you, sir.
Okay, thank you so much, Edmar, for presenting your work. So we will move on to the next presentation. 1 second.
Jessica, how many papers still left?
More two, ma'am.
Including this one?
Yes.
Okay. Okay, done.
Yes. So next we have with us Nimade Prasivi Bestari. Are you there in the meeting?
Yes, I'm present.
Yes, so she is here with us to present her work titled as Smart Technology Adoption in Tourism Operations for Innovation and Sustainability Outcomes, a systematic literature review. So I request you to please share your screen and start with your presentation.
Okay, thank you. Let me just share my screen.
Yes.
Okay, can you all see my screen?
Yes, it is visible.
Okay, thank you. All right, good afternoon, distinguished chairperson, fellow researchers, the moderators, and also conference participants. Well, my name is Nimade Prasivi Bestari from Universitas Pendidikan Nasional, Bali, Indonesia. And today I'm very pleased to present my research entitled Smart Technology Adoption in Tourism, Innovation versus Sustainability using a systematic literature review. So basically, tourism today, we're talking about tourism 4.0 is very characterized by a data-oriented ecosystem where tourism is currently undergoing a major transformation driven by digital technologies itself. So the emergence of artificial intelligence and the Internet of Things, big data analytics, computer vision, and also blockchains has created what is commonly referred to as tourism 4.0. So in this ecosystem, tourism then become very increasingly data-driven, connected, and very personalized. However, despite these rapid technological advancements, current implementation often focuses on technical efficiency and also infrastructure development and also economic growth. So many destinations nowadays invest heavily in what we may call as hardware construction, while paying very less attention to human-centered design, community well-being, and also sustainability outcomes. So the main problem here is digital tourism strategies itself often prioritize revenue over social inclusion and also environmental health. Therefore, the key question is that are we creating smarter tourism system or simply more technologically advanced tourism system itself? So the research gap on this research is there are three main things. The first one is the macro and micro divide. So existing studies often focus on the smart infrastructure, destination management, and also policy frameworks while neglecting the tourist psychological experience satisfaction and also emotional engagement itself. Second is the sustainability gap. So many studies evaluate technological efficiency, and also innovative performance, but fewer examine how smart technologies contribute to environmental protection and also social equity and also long-term resilience. And also the third is the social gap. So there remains limited discussion on regarding the local communities, cultural preservation, inclusivity, and also social well-being within smart tourism ecosystem itself. The study objective here is basically to address and identify key technological drivers in shaping the tourism 4.0. And second is to analyze how these technologies influence operational innovation and also tourism performance itself. The third is to assess whether smart tourism adoption align with the sustainable development goals. And fourth is to evaluate barriers that may prevent equitable growth, inclusiveness, and also sustainable development. So this study is grounded in three complementary perspectives. So the first is the Tourism 4.0 model. The second is a three bottom line framework, which evaluates the sustainability through economic, environmental, and also social dimension. And third is the Society 5.0, where is a human-centered vision originating from Japan that advocates balancing in technological advancement with human welfare and also societal needs. So this study uses Prisma systematic literature review. So this study input systematic literature review following Prisma guideline to ensure transparency and also reproducibility. So you can see here the Prisma itself. So the search scope using the database covering publication from 2020 to 2025. Initially, there were 600 studies were identified, but after screening and eligibility assessment, 23 high-quality peer-reviewed articles were then selected for detailed analysis. So these studies were examined to identify recurring themes, technological trends, sustainability outcomes, and also governance challenges. So the first main discussion or topic of this research is looking at the technological drivers and also the innovation frontiers. So the first major finding concerned about the technological driver itself, artificial intelligence also here really help or enables to personalize recommendation, predictive analysis, and also automated customers service. That's also in line with the rise of Gen Z travelers and also the use of AI with the Gen Z travelers. And then we have the Internet of Things that facilitates real-time monitoring and also smart destination management, while computer vision and also geospatial analytics really help to monitor tourist flow, crowd density, and also destination carrying capacity. So these technologies contribute significantly to innovation by improving efficiency, enhancing visitor experience, and also supporting evidence-based decision making. So the literature here clearly demonstrates that technology is no longer simply a support tool, rather it has become the backbone of modern tourism ecosystems. But however, the findings also suggest that technological innovation alone does not guarantee sustainable outcome itself. So there are still some problems that needs to be addressed. So here we can see the journey of smart and sustainable tourism itself. So one important message emerged consistently across the reviewed study. So the future tourism does not lie in technology alone. Instead, success really depends on integrating advanced technologies with human-centered, sustainable, and also inclusive destination management, while technology should also enhance but not replace human experience. When we talk about tourism, it's also related to cultural authenticity and also community participation. So this shift really reflects the transition from a purely technological perspective toward a more balanced and also socially responsible approach to tourism destination. The next one is about the triple bottom
Sorry
line.
to interrupt.
So
A quick reminder, you have to wrap up within 1 to 2 minutes.
yeah.
Yes.
Okay. So basically, the second theme is about the triple bottom line, where economic really thinking about the smart technology improve the efficiency and also social, thinking about the empowering social and communities and environmental. It's about protecting our planet, but there are still remaining some challenges within the high infrastructure, digital divide, emerging social issues, and need for sophisticated cooperation between multiple entities. And also the last topic is about the government framework and also adoption barriers. So government really needs to work together and create collaboration and also thinking about human-centered smart tourism. So not only focus on the technologies and how we can adapt with the barriers itself. So future smart tourism really depends on balancing technology, innovation, human-centered experiences, and also inclusive governance through multi-stakeholder collaboration. So in conclusion, we can see that the review demonstrate that AI, IoT, and also computer vision are driving tourism into the tourism 4.0 ecosystem and characterized by connectivity, personalization, and also innovation. But nevertheless, there are still substantial gap remains between micro level technological development and also micro level tourist experience. So furthermore, many implementation fail to incorporate comprehensive sustainability indicators that align with the SDGs itself. So the literature therefore suggests moving beyond tourism 4.0 to a society 5.0 approach. So by embracing society 5.0, we can achieve equitable, sustainable, and resilient smart tourism that benefit people, planet, and also prosperity. I think that's the end of my slide. Thank you for the time. I will give the time back to the moderator or if there are any questions. Thank you.
Thank you for your presentation. Can I just clarify about the methodology that you have used? Since you mentioned that your review includes 23 Scopus papers, am I right, from 2020 to 2025? May I just ask what were your inclusion criteria and what are the keywords that you have used during the search of Scopus papers?
Okay, so thank you for the question. Yes, well, the study really aimed to synthesize fragmented knowledge across smart tourism, AI, IoT, innovation, and also sustainability. So those were the main keyword that I highlighted. So using a Boolean search string combining sectors between tourism and also operation management, adoption, implementation, smart technology, smart tourism, innovation, sustainable development, performance, and efficiency. So the result were then filtered using those keywords and also then using a Prisma, it is narrowed down again after reading the all the abstract. And then it narrowed down to 23 articles or literature that are used for this research.
Okay, so since there are only 23 studies being included in this paper, have you considered doing thematic synthesis?
Yes, there were some thematic synthesis that were used on this research. So the thematic synthesis after reading all the articles, the 23. So based on the 23 carefully chosen sets of empirical evidence, I found three thematic synthesis of smart tourism development, which then I divided into the discussion, where the first one is the technological drivers and the innovation frontiers. Second one is about the triple bottom line of smart sustainability, and the last one is about the governance frameworks and also adoption barriers of smart tourism itself in
Okay.
relation to sustainability.
Okay, thank you very much for the clarification.
Thank
Thank
you
you
for the
and
question.
congratulations.
Okay.
Meenakshi ma'am, any questions?
No questions.
Okay, so for our last presenter, I will give a last call to him. Let me check first he's present or not. Okay.
Please call his name. If he is present with the other IDs, he can just call. He can just revert you back.
Yes, he's actually absent. Menford Mutandavari, is he present or any of his co-authors are present? Okay, I think so. They are not present. So we have come to the end of this session. So I sincerely thank all our authors for their excellent presentations and valuable contributions, and all the participants for being an important part of this international conference. I truly hope that this session was very insightful, engaging, and inspiring for everybody. On behalf of the entire team, we thank you for your continued support, not just for this edition, but all the previous edition of TIBS. We look forward to welcoming you again in the next version in 2027 as well. So all the presenters will receive their digital certificates through emails within 2 working days. And the publication will be live within 7 to 8 months. So we kindly request your cooperation with the TIPS 2026 team. I would also like to extend my sincere thanks to our session chairs, Dr. Randy Joy Venathan and Minakhi Raut, ma'am. Thank you for joining us for the session. And this is a small token of appreciation on behalf of Team TIBS. 2026 and Global Knowledge Research Foundation and partners. So, thank you all once again for your valuable presence here. And before we are officially wrapping up, let's capture this memory. I kindly request everyone to please
Can you please
switch
show
on
the
their.
token of appreciation of Minaki ma'am, please?
Yes.
Please take care of it next time.
Yes. So I kindly request everyone to please switch on your cameras for a group snapshot of this conference. Okay. Thank you so much, everybody, for joining. Stay safe. Take care, everyone.
Thank you.
Thank you. Thank you.